Okay, how you guys doing? Hopefully you guys are doing well. Hopefully we'll be back to seeing you guys real soon here, hopefully next Monday. About ready to start section 3-2. 3-2, if you go on Schoology, you'll see a PDF that you guys can print off or just look off of and do your assignment off that. So hopefully you do that before you watch the video. So we're going to start section 3-2, and it's kind of similar to what we were doing in section 3-1, but a little bit different. We're still talking about inverse trig functions, but it looks a little different. If you were to look at your worksheet, we're going to work through the odds here. Question number 9. The very first question we're going to do is number 9. We're only going to do numbers 9 through 36. 9 through 36. The rest of them you can cross off. They give you the question, the cosine of the inverse sine of radical 2 over 2. You're also going to want to get your unit circles out if they're not already out. Okay, you're going to definitely want to be referring to those. Okay, so what this is saying here is, well, if it's just the inverse sine of radical 2 over 2, it's asking us the sine of what angle is radical 2 over 2, okay? So they're looking for the angle, okay? So if we look at our unit circle, the inverse sine, or the sine of what angle is radical 2 over 2, if we look at our unit circle, we see that it is, and you can either do it in degrees or radians, it really doesn't matter, okay? I mean, you're supposed to do it in radians, but it'll actually be okay with degrees on this, and you'll see why in just a second. I've been covering up cosine here. So, and it's cosine, it's not inverse cosine. Okay, so if we look at our unit circle, remember radical 2 over 2, the sine is radical 2 over here, radical 2 over 2 over here at 45 degrees. It's also radical 2 over 2 at, the sine is radical 2 over 2 at 135 degrees, but you know we have to look at the right-hand side of the unit circle. So this right here is 45 degrees. So this is the number 45 degrees, okay? The inverse sine of radical 2 over 2 is 45 degrees. Well, I've been covering something up. I'm going to take my hand off now. We're taking the cosine of 45 degrees. So the answer is radical 2 over 2. This is radical 2 over 2. So what it's basically doing here is this. It's telling you what the sine is. They're asking you what the cosine is. Okay? So here they're asking for the angle. Whatever that angle is, take the cosine of it. Okay? So that's all it is. They're mixing our trig functions. Before it was like the inverse sine of the sine or the cosine of the inverse cosine. Here they're mixing up trig functions. Okay? So basically, again, all it's saying is sine is this. What's the cosine? That's all it is. These look a little harder. I actually think they're a little bit easier. Okay? Number 11, it says the tangent of what? Inverse cosine of negative radical 3 over 2. Okay, so again, we look at our unit circle. Do this part first, okay? Inverse cosine of negative radical 3 over 2. That's telling us that cosine is negative radical 3 over 2. Well, if you look at your unit circle, cosine is negative 3 radical 3 over 2 over here at 150 degrees, I believe it is. Okay, 150 degrees. It's also at 210 degrees. Cosine is negative radical 3 over 2, looking at your unit circle. But we want to have the top half. Okay, we want to have the top half. So this right here, this is the angle 150 degrees. That's the angle 150 degrees. But they want the tangent of that angle. Again, they're saying cosine is negative radical 3 over 2. What's the tangent? Okay, and if we look at our unit circle, the tangent is negative radical 3. Ah, that looks terrible. So our final, it's just this. It's just, there's only one answer here. Okay, all of this is just radical 2 over 2. All of this is just negative radical 3. You don't need two answers. It's just one answer. Okay, so number 13. 13, we have the secant of the inverse cosine of what? 1/2? Where are we at here? 1/2. Okay, so again, we look at our unit circle. This one actually has a really shortcut on this one, but we'll do it the longer way, which is not that long. Okay, so we find out where is cosine 1/2. Well, cosine is a half up here at 60 degrees, and it's also a half at 300 degrees, but we have to have the top half for inverse cosine. So this is 60 degrees. The secant of 60 degrees. Well, to find the secant of 60 degrees, you just flip the cosine of 60 degrees. Well, we already knew the cosine was a half, so since these are reciprocals, it's just going to be 2 over 1. Okay? We couldn't do that back here because tangent and inverse cosine, they're not inverses. Cosine and inverse sine, they're not inverses. So it's just 2 over 1, which is 2. Okay? They're telling you cosine. Just think, you knew this actually months ago. They're telling us cosine. They're asking for secant. You just flip it. That's how you find it. Okay? How you find secant is you flip cosine. We knew that a long time ago. 15, we have cosecant inverse tangent of what? Of 1, okay? Well, we look on our unit circle, okay, and we ask ourselves, where is tangent 1? Well, there's 2 spots where tangent is 1, okay? It's 60 degrees, and it's also 240 degrees. But we have to have the right side of the unit circle in order to find inverse tangent. So they're asking us for the cosecant of 60 degrees. So we're still looking at our unit circle. To find the cosecant of 60 degrees, we find the sine of 60 degrees, and we flip it. Sine is radical 2 over 2. And if you guys remember the little shortcut I showed you guys, the reciprocal of a radical over the same number is just that radical. It's just radical 2. If you want to do it the longer way, you flip radical 2 over 2, you have 2 over radical 2. Can't have a radical on bottom though, so you times the top and the bottom by radical 2. 2 times radical 2 is 2 radical 2. Radical 2 times radical 2 is radical 4, which is 2. And the 2's cancel and you're still at radical 2. Okay? So, I mean, you don't have to do that as long as you remember that little shortcut. Okay? So again, all this section deals with is they're giving you a trig function and they're asking you for, I'm sorry, they're not giving you a trig function. They're telling you a trig function's value and they're asking you for a different trig function of that same angle. Number 17. We just did 17, didn't we? No, I take that, it was only 15. So sine of the inverse tangent of negative 1. Okay, that looks terrible. Okay, so we find out where tangent is negative 1. Well, tangent is negative 1 in 2 spots. It's negative 1 at 315 degrees, and it's negative 1 at, 135 degrees? So we have to look at the right-hand side for inverse tangents though, so it's 315 degrees. They're asking us for the sine of 315 degrees. And you just look at your unit circle, sine of 315 degrees is negative radical 2 over 2. Okay? I mean, it's kind of like this. If I gave you something like the sine of the square root of 900, okay? Well, what they're doing here, this is the square root of 900 is a number. In my degrees here. That's the same as the sine of 30 degrees. This is the number 30. This right here is the angle 315 degrees. So find the sine of 315 degrees. That's all it is. Okay? They're giving you one trig value. They're asking for another one. 19. I don't expect you guys to do this and watch this whole video all in one sitting and do all the assignment in one sitting. I mean, this, it's like usual. This takes probably 3-4 days. What do I have down here? We're going to start section 3.3 on Friday of this week. So, I mean, as long as you have this done by Friday. If you want to get it done in one day, great. But you have nothing to do until Friday. So, it's your call. Okay, number 19. We have the secant of the inverse sine of negative 1/2. Okay? So, we look on our unit circle. Where is sine negative 1/2? Well, there's 2 spots where it's negative 1/2. At 330 degrees and also at, 210 I think it is. But again, we have to have the right-hand side of the unit circle to find inverse sine. So I'm asking for the secant of 330 degrees. Well, to find the secant, we get the cosine first and then flip it. The cosine at 330 degrees is radical 3 over 2. That's the cosine. So flip that to get secant. So you have 2 over radical 3, which is unacceptable, times radical 3, times radical 3. You have 2 times radical 3 over radical 3 times radical 3, which is radical 9, which is 3. So 2 radical 3 over 3. Number 21. Now this is an old problem. I say old, it was from last week, okay? It says the inverse cosine of the cosine of 5 pi over 4, okay? These aren't mixing them. Inverse cosine, cosine, okay? Unlike here where we have inverse tangent sine, inverse sine secant. These are total inverses, okay? Same trig function and it's inverse, okay? So if you remember, the shortcut is just cancel them off. Just cancel them off. 5 pi over 4. That may be our answer. It might be our answer, okay? We got to ask ourselves, though, for inverse cosine, remember it's got to be on the top half of the unit circle. Well, 5/4 pi. Well, 4/4 is a whole pi. So that's 4/4. 5/4 would be right up there, okay? So are we looking in the right spot? No. It's got to be on the top half, we said. This is on the bottom half. So, again, I really wish that we had you guys in class right now, that you guys could come up here and do this, because I usually like to have a student come up here and mark on the board where we should be looking at. And it's a real simple thing to do. I mean, it's hard to see at first, but once somebody shows it to you, it's real simple to see, I think, okay? we have to look at the top half. So what I want to know is where could I draw a point that has the exact same cosine value? And it would be right here, straight above it. It's off a little bit because I'm not a very good drawer. Okay. And the reason why they have the same cosine value, they both went to the left the same amount. Yeah, I mean, well, this one went up and this one went down. Yeah, up and down sign. Left and right's cosine. These went to the left the same amount. So let's think of pizza here. This is a whole pizza, so 4/4 of a pizza. So that right there is another fourth. 4/4 and 1/4 is 5/4. So this little slice is a fourth of a pizza. And this little slice is a fourth of a pizza because they're the same. Well, this is a whole pizza, and this is a fourth of a pizza. This right here has to be 3/4 of a pizza. This is what I was talking about in the last section, that these ones can be very, very simple, and they can be really difficult also, okay? Some of them can be really difficult. A lot of times they just cancel out, you're done, okay? It's not always the case, though. Okay, we have one more that's an older problem. That's number 23. 23, we have the inverse sine of the sine of negative 7 pi over 6, okay? So again, this is similar to what we just did, okay? We just cancel these off, okay? So we just put negative 7 pi over 6. But then we have to ask ourselves, is that okay? Okay, let's draw a picture here. Where is negative 7/6 pi? Well, 6/6 is a whole pi. And if it's negative 6/6, it'd be going this direction. That's negative pi, negative 6/6. So negative 7/6 would be right there, okay? Are we looking in the right spot? Well, inverse sine's got to be on the right side. This is on the left, so that's no good. So we need to draw another angle that has the same sine value, Now be careful here. You might be thinking, well, we just did that. You just dropped it straight down here. These ones have the same cosine value because they both went to the left the same amount. To have the same sine value, it's got to be over here. These both went up. This angle and this angle, that looks off a little bit, both went up the same amount. Okay, so this is the point we need to be looking at. Okay, so let's talk about pizza here. This is a whole pizza, 6/6 of a pizza, and this is 7/6, so this must be 1/6 of a slice. 6/6 and 1/6 is 7/6. If this is a sixth of a pizza, this has to be a sixth of a pizza, and it's going this direction, so it's positive 1/6 of a pizza. So positive pi over 6. Okay, another one's kind of tricky. 25. Okay, this is where I think they get easier when you do this. Okay, now it says find the tangent of the inverse sine of 1/3. Okay, so this isn't like the last two problems. These are totally different. Okay, it's not inverse sine of the sine or the inverse tangent of the tangent. It's a tangent of the inverse sine of 1/3. So we look at our unit circles. We ask ourselves, where is sine equal to 1/3? Well, if you look at unit circles, there's nowhere on your unit circle that says sine is 1/3. Okay, so your unit circle ain't going to help on this one. Okay, for the rest of these problems, I don't think your unit circle is going to help because you're not going to find these values written on your unit circle. So what do? If you can't see on the unit circle, you draw a picture. Sine is 1/3. Sine is positive 1/3. Well, sine is positive up. So it's either got to be here or here. Now, if you're wondering which one do I draw it in? Well, inverse sine's got to be on the right side, so you may as well put it over here. If you're going to draw it over here, you're going to have to erase it and put it over here eventually. It's got to be on the right side. So we just draw an angle here, a triangle. Okay, anywhere in there. It's got to be up, though. And I'm going to label this theta. And from the second day of school, we know that sine is opposite over hypotenuse. So opposite 1, hypotenuse is 3. We need to find out what this side is. We'll label that x. That is not a special triangle. So what we need to do is use the Pythagorean theorem. X squared plus 1 squared equals 3 squared. X squared plus 1 squared is 1, 3 squared is 9. Subtract 1 to each side. X squared is 9 minus 1, which is 8. Then we square root it. So you have plus or minus radical 8. Well, that does simplify. Radical 8 breaks down to radical 4, radical 2, and radical 4 is 2, radical 2. Now this is plus or minus 2 radical 2. Which one is it? Well, it's to the right, so it's positive 2 radical 2. Now we're not done, okay? They told us that, and the thing is, I don't know what this angle is. And they're not asking for the angle. They're asking, what is the tangent of that angle, whatever it is, okay? So we don't need to know what the angle is. we need to find the tangent. So we take the tangent of this angle. And tangent is opposite over adjacent. So 1 over 2 radical 2. And we can't have radicals on the bottom, so we times the top and the bottom by radical 2. 1 times radical 2 is radical 2. Radical 2 times radical 2 is radical 4, which is 2 times 2 is 4. So radical 2 over 4. Okay? So basically, if you have a trig value that you don't see written on the unit circle, draw a picture. Okay? Yeah, it's nice to just look at the unit circle and say, here's the answer, but I think it might even make more sense if you actually draw a picture on this. So when we say secant of the inverse tangent of 1/2, now you might be going, I see 1/2 on the unit circle, not for tangents. You see 1/2 for sines and cosines, but not for tangents. So tangent is 1/2. Tangent is positive 1/2. Tangent's positive here, and tangent's also positive here. And we need to draw it on the right-hand side, so let's draw a triangle in here, a right triangle in here. Here's theta. So again, we're not going to find what the angle is. I don't care what the angle is. I care what the secant of the angle is. Well, tangent is opposite over adjacent. Opposite is 1, adjacent is 2. Let's find out what this is. So Pythagorean theorem, 1 squared plus 2 squared equals x squared. 1 squared is 1, 2 squared is 4 equals x squared. 1 and 4 is 5 equals x squared, and then we square root it. So x is radical 5. And it's plus or minus, but if you guys remember, the hypotenuse is always positive because I told you it was, okay, because I said so. We got to find the secant. Well, for secant, you flip cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, okay? So hypotenuse is radical 5. Radical 5 over adjacent is 2. And that's okay because you don't have any radicals in the denominator on bottom. Okay. 29. Okay, it says the cotangent of the inverse sine of negative radical 2. Now you might be going, oh, well, there's negative radical 2 over 3's on our unit circle. No, there's not. There's radical 3 over 2's, not radical 2 over 3's. So again, we draw a picture that is negative. Yep, okay. So sine is negative down. So we want to put it in this side though, because inverse sine's got to be on the right-hand side. So we draw our triangle, our right triangle, and here's theta, which whatever the angle is, I don't really care what the angle is. Sine is opposite, negative radical 2 over hypotenuse is 3. And this has to be negative because it's going down, and the hypotenuse has to be positive because it's always positive. So we got to find out what x is. Again, Pythagorean theorem. X squared plus negative radical 2 squared equals 3 squared. X squared, when you square a negative, you get a positive. Radical 2 times radical 2 is radical 4, which is 2, equals 3 squared is 9. Subtract 2 to each side. X squared is 9 minus 2, which is 7. So x equals radical 7 plus or minus. It's got to be positive radical 7 because it's going to the right. Again, we're not done. We got to find the cotangent. Cotangent, you flip tangent. Tangent is opposite over adjacent. So cotangent is adjacent over opposite. Adjacent is radical 7 over the opposite is negative radical 2. We times the top and bottom by radical 2 to get rid of the radicals on the bottom. Radical 7 times radical 2 is radical 14. Radical 2 times radical 2 is radical 4, which is 2. So radical 14 over negative 2. Okay, 3 more to go. And again, I don't expect you to necessarily watch all of this the first day. You know, I would suggest you, do a few problems and then try a few problems on your own and so forth. Whatever works best for you though. So, for the sine of the inverse tangent of negative 3. Okay, so tangent is negative 3. And you might be thinking, that's on the unit circle. No, it's not. Radical 3 is, not 3. Okay, so tangent is negative. Tangent's negative here and here. So it's got to be on the right side, so we're going to draw it in the 4th quadrant. Here's theta. And you might go, well, it's just negative 3. It's supposed to be something over something. Well, make it a fraction over 1. Negative 3 over 1. So tangent is opposite, negative 3, over adjacent, which is 1. And the negative is in the correct spot because 1 must be positive because it's to the right. 3 has to be negative because it's down. We gotta find out what x is. 1 squared plus negative 3 squared equals x squared. 1 squared is 1, 3 squared is 9, is x squared. 1 and 9 is 10 is x squared. We square root it, and x equals plus or minus radical 10. It's got to be positive radical 10 though, because hypotenuse is always positive. I'm checking this. My computer just fell asleep on me. Hopefully it's still taping. Yes, it is. Okay, and they're asking for the sine. Well, sine is opposite over hypotenuse. So negative 3 over radical 10. Can't have radicals on the bottom though, so we times the top and bottom by radical 10, times radical 10. Negative 3 radical 10 over radical 10 times radical 10 is radical 100, which is 10. Okay, 33. 2 more to go, I think. 33. So we have the secant of the inverse sine of 2 radical 5 over 5. Okay, so sine is positive 2 radical 5 over 5. Sine is positive up. Inverse sine has to be on the right side, so we draw our angle up here somewhere. Okay, sine is opposite over hypotenuse, so 2 radical 5 over 5. We got to find out what x is. So, use the Pythagorean theorem again. X squared plus 2 radical 5 squared equals 5 squared. So x squared is x squared plus, a lot of students struggle with this, 2 radical 5 squared. You have to take, that's the same as 2 radical 5 times 2 radical 5. Times 2 and 2, you have 4. Radical 5 times radical 5 is radical 25. Radical 25 is 5. So 4 times 5, which is 20. Okay? You times 4 and 5 equals 5 squared is 25. Subtract 20 on each side. X squared is 25 minus 20, which is 5. Square root it. So we have radical 5, either plus or minus, but it's got to be plus because it's to the right. And what are they asking for? The secant? Well, secant is when you flip cosine. Cosine is adjacent over hypotenuse. So we need to find the hypotenuse over adjacent in order to find secant. So hypotenuse is 5 over adjacent is radical 5. We can't have that. Times the top and the bottom by radical 5. 5 times radical 5 is 5 radical 5. Radical 5 times radical 5 is radical 25, which is 5. The 5's cancel. You're left with just radical 5. Just radical 5. Okay? One more. Okay, so we have number 35. Inverse sine of the cosine of 3 pi over 4. Okay, so this is a number, and this one I lied. I said that you didn't use unit circle anymore. You can use unit circle on this one, okay? Because you can find the cosine of 3 pi over 4. You can find that, okay? If you look at a unit circle, the cosine of 3 pi over 4 is negative radical 2 over 2. Okay, that is the number, negative radical 2 over 2. But I want the inverse sine of that. So, I want to know where on the unit circle is sine negative radical 2 over 2. Okay, well, there's 2 spots where sine is negative radical 2 over 2. It's right here at, what is that, 225, and right here at 315. Okay, well, it can't be on this side. It's got to be over here. Okay, so I want to know what is that angle. Okay, I want to know, inverse trig functions ask you what is the angle. Okay, so what is this angle right here? I'm going to go, well, it's 315. That's what Kale just said. It's 315 degrees. No. Okay, it's not 315 degrees because you're looking in the right spot, but that's, and let's make them into radians first off. It shouldn't be 315 degrees. It should be 7 pi over 4. Okay, now you're looking in the right spot, but you can't have something bigger than, it's got to be, remember, inverse sine's got to be between negative pi over 2 to positive pi over 2. Well, that's too big. So instead of going 7/4 of a pi here, we need to go this way. This right here is 7/4. This would have to be 1/4 because altogether it's 8/4, which is 2. So 1/4 pi, but we're going in this direction, so it's negative. And that works because negative 1/4 is between negative half and positive half pi. Okay? Okay, so anyhow, I would suggest watching this video at least a couple times. Don't do all the problems all at once necessarily. You know, spend a couple days on it. Do a few problems each day. If you have questions, just email me and I'll get back with you. And we are going to have a new video over section 3.3 on Friday. Okay, and we'll have a homework quiz over this section probably the Tuesday after we come back. So you don't have to get this done right away, but don't fall behind. So this Friday, the 13th of November is when we'll have our next video on section 3.3. Hope to see you guys soon.